Hey Astro Thinkers, welcome to Nemesis Physics. Today we are going to find out how long can a star live. Or in other words, we will be able to calculate the lifespan of a star like our Sun after watching this video. So make sure to watch the video completely till the end. Coming back to the video, to know the lifespan of a star, we need to know the mass and the luminosity of the star. As mass represents the hydrogen in the star, as the stars are almost completely made of hydrogen. And stars fuse hydrogen into helium in their cores and converts a little mass of hydrogen into energy, while this reaction is known as nuclear fusion reaction. If a star fuses more hydrogen, then it will have higher luminosity and higher surface temperature. If it has higher luminosity, means it has more mass and it's consuming its hydrogen fuel more frequently, so it will be out of hydrogen and die one day. So the period between the birth of the star and the end of the hydrogen fuel is known as main sequence, and we are going to calculate this time period in this video. For that we need to know the luminosity. We can calculate the luminosity by a formula. Luminosity equals to energy by time, as we can say luminosity is defined as energy emitted by a star in a given time. And we can go even more deep by using Einstein's famous energy mass equation, E equals to mc square, by taking energy emitted by star as E equals to Fmc square, where Fm is the fraction of mass converted into energy in the nuclear reaction. By combining these two equations, we get time period is very close to mass by luminosity. And by using some more relations like mass-luminosity relation, where mass is directly proportional to luminosity, as I said, if a star having more mass will also have more luminosity, as it will fuse more hydrogen in its core and convert it into helium and produce enormous amount of energy. From the mass-luminosity relation, we get luminosity is very close to mass of the star to the power of 3.5. And substituting it in the mass by luminosity formula, we get time period is very close to mass of the star by mass of the star to the power of 3.5, which is time period is very close to 1 by mass of the star to the power of 2.5 or mass of the star to the power of negative 2.5. By now you would have known that lifespan of a star is inversely proportional to its mass. So if we take this relation in the case of Sun, we get lifespan of Sun is inversely proportional to the mass of the Sun. So if we take this relation in the formula we get that the lifespan of the star by lifespan of the Sun is very close to mass of the Sun by mass of the star whole to the power of 2.5. If we take the mass of the Sun as 1 and the lifespan of the Sun as 10 billion years, which was found by the scientists in their research on the Sun, we get the lifespan of the star as 1 by mass of the star to the power of 2.5 into lifespan of the Sun, which is 10 billion years. So now we have a formula to calculate the lifespan of a star like our Sun. So let's test this formula on some well-known star. No, I'm not talking about the Sun, I'm talking about the stars that are like our Sun. And one of such star is Vega. Vega is the brightest star in the constellation of Lyra. It is a Sun-like star and it has a mass of 2.14 times that of the Sun and is 25 light years away from the Earth. When we use this formula to find its main sequence lifespan, we get it as 1.5 billion years by using a calculator, which is just 15% of that of the Sun's lifespan. If you have observed here, just 2 times the mass of the Sun of a star has decreased its lifespan to 15% of that of the Sun. You can imagine how young the supermassive stars are going to die if this formula was exactly correct for them. But no, it was not. This formula is not applied for the supermassive stars or red dwarf stars, which are very low massive compared to our Sun. If we use this formula on these stars, we get incorrect value of their lifespan. So let's check it out with a star that has a mass of 0.12 times that of the Sun and is also the closest star to our Sun. It is Proxima Century, which is a red dwarf star. If we try to calculate its lifespan, we get it as 1.9 trillion years, which is very close to 2 trillion years, which may be correct because scientists estimate red dwarfs could live for trillions of years, and we can't predict the exact lifespan of these stars because we have not done enough research on this. as the red dwarf stars can live for trillions of years and our universe is just 13.7 billion years old, we don't know much anything about these red dwarf stars. When we try to find the lifespan of a smaller star like a red dwarf star, this formula can be quite correct. But when we try this on a very massive star, which is more than 40 times the mass of our sun, we will get totally surprising values that are not even close to our predictions. I think I may be confusing some of you. So let's take an example of it. Let's try the most massive star ever discovered, R136A1, which is located at the center of a star cluster named R136. In our satellite galaxy, which is called Large Megalithic Cloud, the star is about 163,000 light years away from us. Its mass is estimated to be 265 solar masses or even more. So let's find its lifespan. From the formula, we get the lifespan of R136A1 as 8,747.5 years. Wait, but scientists estimate the star has a lifespan of 7 to 9 billion years, but it's not even close to this number. So we can say this formula is not for the supermassive stars or the light massive stars like red dwarfs or brown dwarfs. Okay guys, if you got to know something new from this video, then please click the like button and don't forget to subscribe. And on the bell icon to get all my upcoming video notifications. Share this video with your friends so that they can also know some good stuff. Okay guys, thanks for watching and I hope to meet you guys in my upcoming videos.